Objective is to factor a difference of two squares. The easiest example of factoring a difference of two squares is one like this, where you have two perfect squares with a minus sign in between. The square root of a is a. The square root of 16 is 4. You need a plus and then a minus version of this, and that is your final answer. On this one, there are two perfect squares. You have 4c to the second and 25. Find the square root of each one. So it's 2c plus 5, and then 2c minus 5. If you don't know the square roots, use a calculator to do this. And this part. For variables, it's easy. If it has a square symbol on it, then it's a perfect square. Also, if the power is even, that would be a perfect square, as well as this one, and so on. Those would be perfect squares. Square root of 9a squared is 3a. And then square root of 36 is 6. So it's 3a plus 6, 3a minus 6. If you try to do this another way, you can factor out a 9 and be left with a squared minus 4. If you do that, you have 9 times a plus 2 and then a minus 2. That is also an answer. The square root of 16x squared is 4x, and the square root of 100 is 10. So 4x plus 10, and then 4x minus 10. Now in this example, you have 4a squared minus 64. There are one of two ways that you might be able to do this. So we could check by factoring by 4 first. If you take a 4 out all the way through, this is what you're left with. 4 times the quantity a squared minus 16. This is a perfect square in here, a difference of two squares. So you would have 4 and then a plus 4 and a minus 4. Anytime you can factor something out, do that. That's going to be our rule from now on, so that everybody's on the same page. Square root of a squared is a, and the square root of 16 is 4. You need a plus and then a minus. If you factor out a 5x from this one, you're left with x squared minus 25. Now a difference of two squares is in there, so keep your 5x. The square root of x squared is x. The square root of 25 is 5, and you need to alternate signs. Well, clearly 3 is not a perfect square, and neither is 27. Now these two are, so maybe we can factor out a 3 and be left with a difference of two squares. So by doing that, we're left with a perfect square there, and 27 divided by 3 is 9. 9 is a perfect square. The square root of a squared b squared is just ab. And then the square root of 9 is 3. So you also need an ab minus 3. There we go. Clearly, 8 is not a perfect square, and neither is 98. So we may be able to factor it to see if we can get a perfect square in each spot here, a difference of two squares. Let's try dividing by 2 and get 4a squared minus 49. Perfect square, perfect square. Square root of 4a squared is 2a. And then we'll have plus 7, that's the square root of 49, and then 2a minus 7.